webinar, part of the Cisco Meraki webinar series. I'm sorry we're getting a bit of a late start here, a couple minutes late. My name is George, and I'll be walking you through some slides today, and we'll also have a chance to look at a demo. Just to go over the agenda real quick, first thing we're going to touch on is an introduction, a bit about Cisco Meraki. We'll talk about why someone might want to choose Cisco Meraki or a cloud networking solution. Then we'll go into the heart of the presentation, which is going to be a product demo. We'll then circle back after that, talk a little bit about the technology and the architecture behind Cisco Meraki. We'll look at some case studies and the different product families, and at the end we will have some time for a Q&A session as well. I will also mention that I have my colleague Rachel in the room with me today, and she's going to be answering questions throughout the presentation. So definitely would encourage you to ask questions using the questions tool there as they come up throughout the presentation, because it does tend to get a bit crowded at the end. Also, just want to remind everyone that as an IT professional attending the presentation today, you are eligible to receive a free access point. It's a Cisco Meraki 802.11n AP with a 3-year cloud management license, just like the ones that you see there. So best way to get to know Meraki is to try it in your own environment, and we definitely want you to do that. So we ask that you call and confirm your shipping information with your Cisco Meraki rep in your webinar reminder email. We just want to make sure that that AP is going to somewhere where it's going to be tested out, where it's going to be tried in your environment, not ending up on some random doorstep somewhere. With that, we'll jump into the actual presentation here and get started. As I mentioned, first thing we're going to discuss here is a little bit about our origins and how we've evolved to become the leader in cloud managed networking. So Cisco Meraki is a complete 100% cloud managed networking solution. We do offer wireless as well as switching, security, and mobile device management, all centrally managed over the web. Today we're obviously going to be focusing on wireless, but we do offer a full suite of cloud managed hardware there. So we are built from the ground up for cloud management, and it's an integrated hardware, software, and cloud services solution. Since our inception in 2006 by some research students at MIT, we've experienced growth to tens of thousands of different customer networks across all different industries and verticals. We are experiencing over 100% annual growth. And we have been recognized for this innovation and growth, especially in our wireless in the Gartner Magic Quadrant, and also received some of the accolades that you see there, and are proud to be supporting the customers, some of the customers, just some big ones there that you see at the bottom. So why cloud managed Wi-Fi? Why is that a better solution? What are the conveniences, and sort of why would you pick cloud managed Wi-Fi over just sort of a traditional controller solution? And so really the benefit is that we are able to bring all the benefits of a cloud networking solution to the enterprise network. So you can see that you have all of our 4 different product lines. You have our Cisco Meraki MR line, which is our wireless, which, as I mentioned, we're going to be focusing on today. But we also have our MX, our MS, and our Systems Manager product, our mobile device management product there. All those different products are managed from that single pane of glass there that you see. It's just a web application, runs in any browser. We call it Dashboard. And so really the benefit is you're able to monitor your networks, you're able to make changes to your network, run tests on your network, see what's happening on your network, all from a single pane of glass anywhere where you have an internet connection. So if you have an internet connection, you can make all those changes and monitor your network as needed. All this sort of allows the IT professionals of the world to solve new IT challenges. So first, you can ensure your customers can connect the devices that they bring in, and so in a BYOD environment, but also manage your devices that are company or organization property as well, and manage those different devices with different levels of security, as well as managing all your hardware and infrastructure alongside those. Additionally, you're going to be able to guarantee security for the sensitive data that's passing across your network, and also alongside that provide easy one-click guest access for your guests and visitors. And of course, across all these different types of traffic, you'll be able to prioritize the bandwidth across your network and to the internet with global and application-aware firewall and traffic shaping rules. Now we'll jump into the heart of the presentation, which is going to be a live demo here of our Cisco Meraki network. So what I'm going to do is just jump out of PowerPoint here and actually go right over just into Chrome. I've actually logged into Dashboard prior to the presentation today, but when I log in just in a browser here, it drops me right at this page. And so what I'm looking at is actually a view of our worldwide distributed network for Meraki Corp here. So we can see that we have a number of different offices. We have maybe some teleworkers here across the U.S. And in Canada we have our main office here in San Francisco, which was what we're going to be focusing on today. But we also have our London office and even have our Sydney office here as well. And I can use this page right here to look at just a particular network. So I can type in, for example, just wireless, and it's going to show me all of my wireless networks. Or I could type in a location such as, say, Sydney, for example, and that's going to show me all of my Sydney different networks there. As I mentioned, what I want to look at today is actually going to be our main corporate site here in San Francisco, our main campus in San Francisco. And so what I'll do is just click into Meraki Corp. And this is actually going to bring me into a view of all the client devices that have connected to the network for the past day. Now, today we're going to be focused on wireless, so what I can do here is just use this drop-down menu to select just my access point clients. I could also get more granular, so if I wanted to look at just my internal wireless devices or just my guest devices that have connected to the network, I could certainly look at that, and that's going to be on a per SSID basis. Today we'll look at just all of our access point clients. And so again, we're looking at for the past day, but it might be a bit more interesting to look at for the past week here. We can see sort of the cyclical nature of traffic that's been passing across the network. Obviously here we have the weekend, not a lot of wireless devices in the office on the weekend, not a whole lot of people working versus on every other day here where we have a relatively large spike up into 30 to almost 40 megabits per second. In addition to just general traffic, I can also see all of my devices here. So I can see that we have 765 different client devices that have connected to the network. And we can see that we're pulling in information from all these devices automatically, actually. So the description here is going to be either the net BIOS if it's a Windows device or a bonjour name. And like I said, that's populated completely automatically. The IT administrator doesn't have to go in and name all their devices in Dashboard. We're going to use our device fingerprinting techniques to identify the device description and also the OS that's on the particular device as well. So we can see if a device is a Mac OS 10 device or if it's a Windows 7 device or maybe Android here as well. And we can use that data to actually search for a particular device. So if I wanted to search for say just our Windows computers here, our Windows 7, I can type in Windows 7, and that's just going to show me all my Windows 7 devices. It's actually going to show me as well the breakdown of traffic that's contributed to the total network traffic on the wireless from Windows 7 devices. We can see that in the yellow here on the bandwidth graph. And if I wanted to search for a device type rather than a device OS, I can certainly do that as well, such as searching for maybe iPads on the network. I can type in iPad and it's going to show me all of my iPads. Looks like 33 out of 765 total devices in the past week have been iPads. Now, if I wanted to actually see the traffic that was being passed by an individual device, I can click on one of these. So I'll just pick on one of these, for example, here. This particular device is a MacBook Pro. We can see that it is on Meraki Corp as its SSID. It's connected to the access point 4B5. So we're actually going to hyperlink you directly to the access point page here right from the client device. We get some information right from here about this particular client's device signal strength, their login information. We can see which users logged in. So this information right off the bat could give us as an IT administrator some benefit when we're trying to troubleshoot this particular user. If this user is coming to us and complaining that they're having slow speeds for some reason, we could use the information about their signal strength and which AP they're connected to. We could even dive into the AP and see potentially how many clients were currently connected to that access point as well. And so it would allow us to have a better idea of why that particular device was having a slow speed, whether it was something to do with its connection to the AP or if it was something in the larger network. We can also see the actual approximation of where this device sits in our floor plan here. So we've actually uploaded a floor plan of our office. I can zoom in and I can actually see here that we're approximating this device to be right over here by these conference rooms on the 4th floor. And that's done using AP triangulation. So we can actually see this device is being approximated to here. It's actually connected to this particular access point, but maybe it's, would be better off connected to these access points. That would let us know that maybe we would need to adjust how our access points are oriented if we have these devices all over here connecting to this AP rather than these, or maybe something's wrong with these APs. Additionally, in addition to seeing just information about this device's connection to the network, we can also see the amount of usage that this device has passed, or the amount of bandwidth that this device has used. So we can see this over the past week. We have one big spike here. Maybe this was this person downloaded a movie or something like that. We can actually see too a breakdown for this individual device what was being passed. So right here we see that this is actually mostly Apple.com video that's been passed, or Apple.com traffic that's been passed, 3.6 gigabytes. We had WWDC here in San Francisco yesterday. A lot of people watching that, so that makes sense. We can also see some other information. Salesforce, we use Salesforce here as well. Email, Gmail, and some other things here. Now, if we wanted to use this information, say we saw a lot of video streaming, or we saw a lot of bandwidth use going to Pandora or other maybe sort of non-business critical applications on the network, we could then put this particular device into a group policy if we wanted to control how much bandwidth they can use. So right here we have this device policy drop-down menu. If I click on the device policy dropdown, we can see we have a few different options. We have a whitelist policy, which is built in. That's going to provide basically unlimited access to the network for this device. Blocked policy is just the opposite. If you select the block policy, you could then specify a custom message, like no more streaming at work, please see IT. And then that is going to put this particular device in a blocked state. It's not going to be able to access anything on the network, and every time it does, it will get this page here that will be forced to come CS to be reinstated with privileges on the network. Now, that seems a bit harsh, maybe. So something that might make more sense and wouldn't totally impede this user from doing what they want on the network would be to enroll them in a group policy that controls how much bandwidth they can use for certain things. So let's say here we have a few options. So this list that we're looking at is actually a predefined list of group policies that our IT administrators here on site have created with all different policies built in, with different bandwidth policies based on layer 7 applications, maybe different layer 7 firewall rules as well, layer 3 firewall rules even, blocking these users from accessing certain IP addresses on the network. So we have some here like bandwidth abuser. That's probably a very locked down one. Throttle video and music might be more appropriate. Maybe we don't want this particular device to be able to use a huge amount of bandwidth to watch videos, so we could put them in a throttle video and music policy on the network. And we'll actually have a chance to look a little bit more in detail about creating group policies there. First, though, let's just go back and look at the main clients page again. So here we are back at the clients page for access point clients for the past week. And you can actually see right here that we have the ability to look at the application breakdown for the entire user base of wireless users here. So we can see most of this traffic, is just miscellaneous web, but we also have some iTunes in here. We have some Windows file sharing, some miscellaneous videos, some YouTube, and so we can actually look in more detail at these applications as well. Beyond just the pie chart, we can expand this out into a more detailed table here, and we can identify really thousands of different applications that are being passed on the network. So we can see we have all these applications that have been categorized on the network here, and we can see them sorted by both usage and then usage within their group as well. So first we identified the description here, and this is before we were looking at sort of our device fingerprinting, our OS fingerprinting here. This is going to be our application fingerprinting techniques. We're actually looking at the IP addresses and ports that are being passed, and we're identifying that traffic as one of these different applications. So we can identify things like iTunes, Spotify, Pandora, SoundCloud, um, and they're actually all placed into a convenient little group here. If we're not familiar with maybe what one of these applications actually is, so rdio.com, I've actually never really heard of that. If I didn't know what it was, it would let me know right here that it's music and not contributing a huge amount to bandwidth usage on the network. Now, I can actually look into one of these applications to see which devices are contributing to it as well. So if I wanted to take a deeper look into, say, iTunes, for example, I can select iTunes, and it'll give me information about both what this actual application is. So it's Apple's media store for downloading and purchasing audio, video, and games. We all know that, but that might be more helpful for a less well-known application there. And we can see the client devices that are contributing to this rule as well. So we can see a number of these devices here have passed, over 4 gigabytes of traffic here, or over 3, I should say. So what we could do is potentially come in here and put all of these devices in a group policy like we were looking at doing before, or what might make more sense is actually to throttle down traffic for, say, iTunes and other video and music applications for the SSID as a whole. So if I go now to the wireless tab here and go to the firewall and traffic shaping page, this is going to allow me to make some changes to my SSIDs. And so we can see here that we have a drop-down menu for our different SSIDs. So we have the Meraki Corporate Network, we have an engineering SSID as well as a guest SSID, and I can make some changes to the guest SSID if I wanted to. So let's say first here, maybe we want to lock down our guest network first. So right off the bat, the first rule that we have here is the Layer 3 firewall rules section, and we actually have this option built in where the policy drop-down menu for allow or deny, and you can see here that the destination is actually just going to be the local LAN. And in the comment section, we've built in this rule that allows you to easily block guest users from accessing the LAN just with a simple drop-down menu here. And so when that's actually selected there, what it's going to do is prevent any device that's on this SSID from accessing any private IP address. So they're not going to be able to access internal servers, they're not going to be able to access user workstations. Of course, if we wanted to, we could add in another allow rule above here so that our guests could access, say, a printer, but not any other resources. So just some nice flexibility with being able to control access to resources right on the LAN for our guests. Additionally, we have the ability to put in place some traffic shaping rules for these users as well. So we can see we have the per client bandwidth limit and as well as the per SSID bandwidth limit. If we wanted to control how much bandwidth our guests coming onto campus were using, we could control that on a global level, so for all traffic on a per client and per SSID basis. So let's say maybe we only want each individual device that comes in to be able to have 500 kilobits per second of bandwidth, but maybe we want to limit our per SSID bandwidth limit as well. So this is going to be the aggregate of users that are connected to an SSID. So let's say we limit that to, say, 5 megabits per second. When I do this, no matter how many users come into my building here and are connected to my guest SSID, they're not going to exceed 5 megabits of traffic on my network, so I can guarantee the rest of that bandwidth is available for my internal users connected to that SSID. So that might make sense for the guest SSID here. The corporate SSID might be a bit more complicated, or we might want to have some more granular rules for the corporate SSID, so rather than throttling down bandwidth altogether for the corporate network. So as I've selected here, I have the corporate network now, and I can skip over the per client and per SSID limits, but maybe I want to actually put in place some layer 7 traffic shaping rules. So I'll add a new rule here, and when I add this rule, I have the ability to select some different categories or applications within those categories. So what we were talking about before was potentially, video and music using up a lot of bandwidth on the network. We have things that we do here that maybe require a lot of bandwidth that are business critical, and so we need to throttle down video and music. So right off the bat, I can just come right into video and music, and I can see what's encompassed in the video and music category here. So I could select just one of these, for example, or I could select a couple like iTunes or Google Video, Netflix here, or I could just go right ahead and select all video and music, and it's going to encompass everything in this list. So that's what I'll do here. I'll select all video and music, and then I'll select a limit of 500 kilobits per second per user. So each device that connects is only going to be tapped out at 500 kilobits per second when they're using these video and music applications. What the implications of that are is maybe someone can go in and they can stream sort of a standard definition video clip from YouTube or listen to music, but they're not going to be able to go into Netflix and watch a full length HD movie at work there and use up all the bandwidth. Now, as I mentioned, we have some other applications on our network that may be more business critical. So if I select another shaping rule here and add in a different custom expression now, so this time I'm going to look at VoIP and video conferencing. Also bandwidth intensive, but business critical in this case because we use Skype, we use WebEx for customer demos and interviews. So all of this traffic like WebEx and Skype is pretty critical here for business. So what I'll do is select those two options, and rather than choosing a different limit here for our internal SSID for video, or excuse me, for VoIP and video conferencing, I'm just going to select to ignore the per client limit, and that's going to prioritize the traffic for those particular business critical applications. Now, additionally, I have these options for Layer 7 firewall rules as well. So before we were looking at throttling down or prioritizing traffic, what if we want to just block traffic to a particular application altogether, say something like peer-to-peer? No reason for there to be peer-to-peer traffic on the network. It's both bandwidth intensive and can be a security threat as well, or a security risk as well, so I could add in that rule. And so really in a couple clicks here on my internal SSID, what I've done is I've throttled down non-business critical things that we don't want to block altogether because people like to listen to music when they're at work. We've also prioritized here traffic for business critical applications that are bandwidth intensive like WebEx and Skype, and we've actually added a layer of security as well to deny traffic to any peer-to-peer device, or any peer-to-peer site, I should say. Now, up until now, so we've looked at sort of configuring some of your different SSID settings. Now, you also have the ability to bring up additional SSIDs here on the access control page. You can set passwords and different permissions, configure a splash page perhaps. You can set up SSID availability as well, so you can have certain SSIDs like your guest SSID broadcasting only during business hours, especially if it's an unsecured SSID. You probably don't want to provide that security risk. So as I mentioned, kind of has just been looking at controlling how our user devices interact with the internet. What if we want to actually look now at how we are configuring our hardware, how we're configuring our actual access points here on the network? So what I'll do here is go to the map and floor plans page. And this page is actually going to show us a overlay again on our floor plan here of all the access points on this particular floor. So right now we're looking at the 4th floor, for example. And this number is actually representative here of the number of clients that have connected, I believe, in the past week here. But we could also certainly look at the number of current clients connected to a particular IP. This is going to give us some pretty good information on our AP distribution in our building here. It'll give us an idea of if we're overloading a particular AP and maybe we need to move an AP. This one here has 36 clients connected. Maybe that one's a little overloaded. Maybe we need to add an AP right here. Maybe we need to spin or move this AP a little bit so that it's handling some of the client load from this part of the building. This view just allows us to see a pretty good overview of how our distribution looks and how our APs are aligned and are being used on our floor here. Now, of course, if I wanted to look at a particular AP and see what was going on with that one, I could just select, say, this one that currently has 36 clients connected. Just click on it right there, and it's going to bring me to the AP detail page. And so this is going to show me information about the name of this AP. So we can see it's AP number 4 and or on the 4th floor in the A10 area of the building. We can see the serial number of this device. We can see the actual street address of where it is. We can see which SSIDs are broadcasting. So we have the ability to scope out SSIDs as well. As I mentioned, you can bring up all these SSIDs. The default behavior is basically, no matter how many APs you add into your network, they're all going to broadcast all the SSIDs. But you certainly could scope that out if you wanted to as well. Using AP tags, you could create a SSID only broadcasting, say, in the IT area for IT purposes only, and it's not going to broadcast on all the other APs in the area. So we can see here that looks like this one is in the main area, so we have corporate, guest, and a test one broadcasting here, but we're not broadcasting the engineering SSID in this particular part of the building. We can also see the LAN IP address and how it's acquired that IP address. So we can see this particular AP has pulled an IP address via DHCP. We could, of course, set a static IP address for this access point right from here. If I just went in here and selected static IP, I can put in all my information, save the changes, and then that access point is going to take down that static configuration on the network. We can also see the usage on this particular AP. So before we saw the current clients, and now there are actually 40 here, which we'll look at in a moment. But we can see that in the last day we've had 118 clients connected. We're currently broadcasting on 2.4 gigahertz channel 6 and 5 gigahertz channel 157. We're connected to a switch here with a gigabit connection. And so this is actually, as a quick aside, a benefit of having Meraki switches as well. You will be able to see and have a hyperlink directly to the port that's the AP is connected to. That being said, you certainly do not have to have a full Meraki stack to use the wireless. You can certainly use the wireless with any other vendor alongside there. But if you do have Meraki switches, you can have some nice tools here to go right back to the particular port. So if I open this in another window or another tab just briefly, it's going to actually show me the port that this AP is connected to. And so there are just some nifty things that I can do here that would allow me to do some troubleshooting. So if this AP was offline, for example, and I wasn't on site, I could do things like run a cable test right from the switch port or cycle the port as well. So I could reboot the AP. Maybe it was hung or something like that, was having some issues. I could reboot the AP right from dashboard by using the switch here, would never have to come on site to have to actually troubleshoot and unplug the AP. Additionally, we can see that we're successfully hooked up to our Radius server here, and we have these live tools at the bottom for this AP as well. We have our usage graph, so we can see we're peaking out around 20 megabits per second on this particular AP. It's varying quite greatly across 40 different clients that are connected to this particular device. We can see most of them are connected at channel 157, so most of them are connected with a 5 gigahertz connection, most connected to Meraki Corp as well, some here on Meraki Guest, and just looks like one device here is connected, and obviously looks like it has a stronger signal strength on the on channel 6, I should say, in the 2.4 gigahertz band. Additionally, I can see information about the channel utilization in the area as well. So we can see here that our channel utilization is relatively high here on the 2.4 gigahertz scale, a bit lower here on the 5 gigahertz. So that could give us information on, if we needed to do some channel planning or power adjustment if necessary. We can also run a ping test on the AP. We can ping an individual client device or just ping the access point right from the internet here, right from dashboard, to make sure that it's responding to pings, everything's online. We can see the latency as well. We could also see things like the ARP table. We could run a traceroute test out to the internet if we wanted to. We can run a throughput test on the AP, blink the LEDs remotely, which is handy if you're working with a technician on site, you're trying to identify which AP they're actually looking at. You can blink the LEDs for them to make sure that they know they're looking at the correct one. And of course, you can reboot the AP remotely as well if you need to. We can also go back and look at sort of an overall view of our access points in a list view rather than on a map as we did before. So if I click on the access points page, this is going to show me all my APs that have been in the network for the past week, and I can see a lot of information about the capabilities of the device, which channels they're broadcasting on, I can see the clients. I can see the current clients as well that are connected. All of this providing me information on how my APs are distributed, if any are getting overloaded, or if any are having any issues. And of course, if I needed to expand my environment as well, if I was adding in some APs, it looks like these are a couple examples of these here that have been added in but have never come online. I can just click this Add APs button here, and that'll allow me to add devices from my inventory to the access point network as I was expanding my facility. Now, there are a number of other cool tools that we can use to get information from a monitoring perspective and a security perspective with the APs. One of those is Air Marshal here. Air Marshal is our wireless intrusion detection and wireless intrusion prevention system. So we can see that we actually have here an overview of all of our APs that are doing scans. So when we're talking about doing scans, that means we're actually using the third radio in the MR18s, 26s, and 34s to do a scan of the RF space to make sure that there aren't any threats, or also find out information about interference. And so that data is all going to be aggregated into this table here below. And so we can see some information about our rogue SSIDs, for example. So these are going to be SSIDs that are broadcasting from access points that have been plugged into the LAN. So if you're a school and potentially a student brought in a Netgear router or an Apple consumer router trying to bypass rules that you have in place, they plug it into your LAN, you'd actually see this come up here as a rogue SSID. I mean, you could actually use the Meraki APs to contain that particular device as well, so that no one will be able to connect to it. But you can also just get information about it. You can see basically, the SSID that's broadcasting. You can see how many APs are broadcasting that SSID. You can add in columns here too for the channel that particular AP is broadcasting on. You can see the manufacturer of that particular AP and the scene by as well, which is going to show you actually which of your Meraki access points saw the rogue AP, which will give you a much better idea of where it is, and then you can couple that with the manufacturer of that particular AP to track it down and get it unplugged on your network. Now, this will additionally give you information on not just rogue SSIDs, but other SSIDs that have been seen in the area. So we can see that this list is SSIDs that, they're not necessarily security threats because they're not broadcasting from our LAN, but they are in the area and therefore provide some extra interference that we might want to have to mitigate or might have to deal with. And so we can get that same information about the SSID. In this case, it might be really useful to see which channel that particular AP is broadcasting on, so we can see, if we need to do some manual channel planning, make some changes to which channels we're broadcasting from our APs based on, these, looks like a lot of these are broadcasting on channel 6 here, so maybe we would want to pick a different channel for our APs here in our office because of these other nearby companies that are broadcasting on the sort of the most congested channel 6. Now, this information can also be seen in a live view as well using the RF spectrum tool. So if I select RF spectrum here, we can see a list of all of our APs. And again, as I mentioned, our MR18, MR26, and MR34s all have a third security radio built in that's generating in real time all this data that we're seeing here. And so we can actually click into each of our APs here. So this one, for example, has a very high utilization on the 2.4 gigahertz band. This is going to bring us into a real-time spectrum analyzer that's going to show us two different views. The first here is going to show us the amplitude of the interference. So right here on the y-axis we have our amplitude, or our level of interference, I should say, the severity of the interference. And across the x-axis here we have, as you can see, our 2.4 gigahertz channel spectrum. Now, over time, this is going to build up some information. And so, as I mentioned, this is how severe the interference is. So when we're looking at the amplitude there, that's what that is. The red and blue, or the range of red and blue, is going to show how frequently we see interference at that severity. So we can see here, the blue, we're not seeing it super severe that often. but we are seeing it sort of at the negative 80 here area very, very often. Our sample size is showing that more times than not we're showing interference at this particular level here of interference. And of course, it's going to show us this across all of our 11 2.4 gigahertz channels. Now, this graph below is going to show us a up to 3-minute sample of the data that's being collected here. So we can see these different bands of interference here. And so again, we're looking blue is the sort of least severe, and then all the way up to red, which is very severe. We can see that what we'd want to look for is something like this, actually. So we can see that over time, consistently, on channel 6, we're seeing a high level of interference, even over a 3-minute sample. So channel 6 and channel 11 here don't look that great. Channel 1 looks less crowded, and actually our auto channel selection algorithm has done a good job. We're actually already broadcasting on channel 1 for this AP. We can also see this showing in a sort of less complex view, I guess. We're going to summarize it in a table here and show you which access points are actually interfering with this particular AP as well on the network here, or other APs not in the network. So these two pages, the Air Marshal and RF Spectrum pages, can be used for just information for maybe a site survey, or we can use them as actionable items to actually make changes to our radio settings. So if I go to our radio settings page now, this is going to bring me to an overview where I can make changes to our individual radios, both on a channel basis, so change what actual channel they're broadcasting on, as well as change the power that each particular radio is transmitting. So just wait for this to load here. And so we can see, again, we're showing this on a map. And so from a channel planning perspective, this is actually showing us the channel that these APs are broadcasting on for 2.4. I could also see the channel they're broadcasting on for 5 gigahertz, and based on the actual power that they're broadcasting, we're going to see these circles either grow in size or shrink in size. Now, if you wanted to make a change to one of these particular APs, we can select one of them just by clicking on that. It's going to indicate that we're editing it through this little red halo here. This is a MR34, so an 802.11 AC capable AP, so we have the ability to change the actual channel width right from here, as well as the channel for the 2.4 gigahertz and 5 gigahertz band radios, and the power as well. So we could manually turn down the power. The auto algorithm does a good job, but as some of you wireless experts out there may know, sometimes wireless is very complicated. It's going to require you to actually do some manual channel planning, some manual adjustments of the actual power, especially for high density deployments. One other last feature that I want to take a look at here is actually going to be our CMX analytics. So this is our location analytics here. So if I select location analytics, this is going to be an org level view. So this could have potentially multiple locations within a single organization or company. And we can see here that we're showing actual data on passersby and people who are walking by our network. So in a retail environment, this comes in handy because we're actually looking at wireless probes that are coming from devices, so iPhones or Androids that have Wi-Fi enabled but aren't actually associated. We're actually picking that data up, and we're able to dump it in here to provide information about who's passing by and how many numbers of people are passing by a particular area. So this data is going to show us, both people who are considered passersby, who are people who just walk by. Visitors are people who stay more than a couple minutes, and then we'll see people who actually connect as well. We can use this data just on an objective basis to see for one particular site, or we can actually compare it as well. So we can compare, so say our corporate network with our Sydney network, for example. So if you were trying as a retail space to deploy sort of an A/B test with a new advertising material or something like that, you could compare how much engagement you got from one site to the other using the CMX location analytics here. Additionally, this is able to be exported through an API as well, so you can get real data on and actionable data on people that are passing by for targeting them with advertising campaigns and such. Furthermore, this data is all aggregated into a heat map as well. So if I go to the location heat map here, we're going to actually take the data from the CMX analytics there and couple it with the RSSI, so the signal strength from AP to device, and we're going to build that out on your map here into a location heat map, and it's going to show you over time the path of traffic in a particular area. So if you're deploying this on a large-scale campus or in a large department store or something like that, you can certainly see where the most foot traffic is going across your floor plan there based on time of day. With that, that kind of concludes our demo here. If you're interested in any more of these features, definitely check out our website there, or feel free to ask questions as we go or at the end about particular features that we didn't touch on. But that does cover a fair amount of our security features, some of our location analytics features, as well as just having control over your users and over your actual wireless infrastructure as well. So with that, we'll jump back into the PowerPoint here and talk a little bit about our architecture. So it's a totally cloud-managed networking architecture. As you can see here, you have your different campuses or headquarters, as well as branch offices, retail stores, teleworkers. All of these devices are going to report back to our cloud here, and so they're securely connected with an encrypted tunnel to the cloud, all through a centralized management platform. So as we were looking just a second ago in dashboard there, you can see all of your different sites, you can see all of your different APs, and they're all going to report back through that single pane of glass into that intuitive browser-based dashboard through a secure connection. Now, that being said, all of that management data is the only thing that we actually see on our servers. So Meraki uses an out-of-band controllerless solution. So basically, we're not going to see any of your user traffic that's passing through the cloud, your users visiting sites and stuff like that. We never see that. It never passes through our servers. We just pass up management data and settings changes that go down to the APs. Additionally, that allows us to be fully HIPAA and PCI compliant. We do conduct third-party security audits and daily vulnerability testing on our servers, and also you're going to get one of the benefits of the out-of-band and cloud management platform is the automatic firmware and security updates, which will provide additional security as well as new features to your devices. In addition to being secure, we are scalable, so you get all the benefits of the controllerless access point model, but it's going to be enhanced by the dashboard keeping tabs on each AP, and you're not going to also get that bottleneck coming back to a controller or what could be considered a single point of failure. We're also highly reliable. We have multiple highly available data centers around the globe that keep dashboard up and running with 99.99% uptime. And as I may have mentioned briefly before, even in the event of any type of ISP outage, your devices will continue to function. Even if they can't contact the cloud, all your devices will hold their configurations. Your APs will still be able to authenticate and associate users, and your LAN will continue to function as normal until internet connectivity is reestablished. If you're interested in learning more about sort of the back end, about security and how Meraki works from that perspective, would encourage you to check out meraki.cisco.com/trust. So as I mentioned, one of the big benefits of a cloud management solution like Cisco Meraki is the scalability. So just a couple examples of some large deployments here: Telmex, Next Retail, Motel 6, Jeffco School District. You can see large deployments there. But I'll mention, a ton of our deployments are just one or two APs. They range in size from just a couple devices all the way up to the ones that you see here. And we are proven in tens of thousands of different devices of all different sizes. As I mentioned briefly before as well, one of the huge benefits of a cloud management cloud managed solution is the ability to have new features delivered in a software as a service model. So we saw some of these features here. These are just some of the highlights. The user device fingerprinting. We looked a little bit at the wireless intrusion detection and prevention and containment there, as well as application firewall and location analytics. So all these new features are going to be deployed down to your devices automatically. You're never going to have to pay anything more for new features. With Meraki, you basically pay for the hardware and you pay for a license. Your license is going to cover all of your new feature deployment, all your security updates, all your support and warranties. So really just two costs with Meraki, your hardware and your license there, which covers everything else. We'll take a brief look at a few case studies here before we jump back and look at the different product lines. So first, Nespresso was able to modernize their customer experience in the retail space, providing guest Wi-Fi, which was securely isolated from mobile point-of-sale systems and their other internal wireless needs. They leveraged the intrusion detection and intrusion prevention to maintain PCI compliance as well. So while Nespresso successfully deployed in the retail space, MIT was able to deploy in education's most technically advanced facilities, which is their CSAIL, or Computer Science and Artificial Intelligence Lab. They were able to support a BYOD initiative while still ensuring that the highly sensitive data of things like new proprietary software and technology was all kept secure. And they did all this using identity-based group policies to firewall off their users' access to certain network segments. They also were able to deploy in a highly challenging physical environment as well. This facility is not easy. It's got a lot of different weird shaped rooms and high density deployment as well. So they were able to use our auto RF optimization tool to deploy successfully in their environment. Moving beyond education, Motel 6 was able to deploy Meraki to support all of their properties nationwide. It was a 10,000 access point deployment with 0 dedicated staff. They deployed to 70,000 rooms across 620 different properties, and they do support 35,000 wireless users every week. Their entire network is managed through a single dashboard, and kind of an impressive timeline there. Their deployment was able to be completed in under 5 months. Now we'll take a look at our different product lines. So we focus mostly on our MR wireless today, which does come in 6 different models, both indoor and outdoor. And those are going to range from our high performance 802.11ac MR34 down to a more value priced access point as well. But I will say all of them are enterprise class silicon. They're all able to support PoE, and they all do have a lifetime warranty for all indoor APs. No matter which AP you buy, you're going to get all of the features that we looked at today, so all the BYOD policies, that application traffic shaping that we looked at on a per SSID basis, easy one-click guest access, firewalling from the LAN, as well as enterprise security, wireless intrusion and detection, as well as wireless intrusion detection and prevention, I should say, as well as mesh routing across APs as well. Some of our other families, which we touched briefly on at the beginning of the presentation, is our MX Security Appliance. It's a next-generation firewall offered in 6 different models. Our MS switches are actually offered in both these Ethernet Edge switch models as well as aggregation switch models, and the Systems Manager mobile device management product. Totally free product. Welcome to try that in your own environment at any time. Just download it for free. So we do provide what is a complete edge and branch hardware portfolio, and all of these different devices here, including the wireless, are managed under that single dashboard there, just a web-based or browser-based application with no install on the computer. So just to review again the benefits of all the different product families, the ability to do multi-site management, huge advantage, very easy to clone branches, very easy to add devices to existing branches. All you have to do is basically add the serial number into dashboard, ship out the device, and it'll automatically download its configuration. In addition, firmware upgrades, basically you just get an email when your device is eligible for a firmware upgrade. We do release them once every 6 months or so, and your device will basically automatically download that firmware upgrade. If you need to reschedule it, you can certainly do that in dashboard as well. We didn't have a chance really to look at the summary reports, but we do generate summary reports for all your data across your different networks or across your different sites, which can then be emailed to you or someone else automatically, or you can email it directly on an ad hoc basis right at the dashboard. We are fully PCI compliant, and again, we do maintain a 99.99% SLA for our backend. If you're interested in trying Cisco Meraki for free, beyond just the AP that you are eligible for today, so remember, to call in to your sales rep today to confirm your shipping address so that you can get that AP and try Cisco Meraki in your own environment. But if you're interested in trying any of our other product lines, we also do offer all of them on a free trial basis. So if you're interested in trying out the MX or the MS switch there, feel free to ask your rep when you call in. We'll help you get started. They set up in about 15 minutes, and we do have a dedicated team even that can help walk you through and get you acclimated to Meraki in your own environment. With that, that concludes our presentation. I just want to now try and address a few of the common questions that we saw here in the presentation today. So just bear with me for a moment here, and we'll see if we can find some common questions. Okay, a couple questions about, let's see, IPv6 integration. So we do support IPv6 currently only on our APs. Not a lot to configure there. We do just support, basically, we can't do any modification of IPv6 traffic, but we will pass the traffic along. Questions about how to get some eval units. Should you go through your reseller or should you go through Meraki? Definitely would encourage you to reach out to Meraki since you do want to come in and or call in and confirm your shipping address so you can get that free AP. It's a really good time to mention that you might be interested in doing a free trial down the road. So you'd want to initiate that conversation with your Meraki rep rather than going directly to your reseller. Some questions, I believe, about roaming between APs. So we do support seamless roaming between our access points. You can run our access points in one of two modes. You can run them in NAT mode for a particular SSID or bridge mode. In bridge mode, you're going to be bridged back to the LAN. You're going to get an IP address from the LAN, and in that way, we support fast roaming. I believe it's 802.11k, I believe, or 802.11r, I should say, actually. And so we do support that standard on a beta. I believe it's in beta testing right now. If you want to try 802.11r, which is basically a fast roaming protocol between APs, will allow you to basically roam between access points more quickly. Really comes in handy, especially with Apple devices, which are sort of notoriously sticky. But we do certainly support seamless roaming. As you walk throughout the building, our APs will seamlessly hand off your device as you roam.